Algebra 1 students, this is Mr. Wilsey, and in this video we're going to be looking at the topic of simplifying radicals. So you're going to be taking down notes with me, not necessarily on grid paper like this. You can take down notes on any kind of paper. Simplifying radicals. Now, to be upfront with you, this is probably my least favorite topic in Algebra 1, so let's try to get through it quickly and as painlessly as possible. Now, first question is, what in the world is a radical, right? Well, you've already seen radicals plenty before. A radical is just that symbol right there. In other words, radical is another way to say square root. Okay? So a radical is just a square root. No problem there. Now, in this video, we're going to learn how to simplify these radicals. Okay? So let me just give you an example, a very easy example, one that you can probably already do. Let's say I ask you to simplify, how about square root of 49, right? That's easy enough to do. You know that the square root of 49 is 7, right? That seems like a cakewalk, but we're going to look at some more challenging examples. But in order to look at the more challenging examples, let's recall what this idea of a perfect square is. 49, as we just saw here, is an example of a perfect square. Do you remember what a perfect square is? Well, first of all, make a list of all of the whole numbers. Remember that whole numbers are the ones that you can count on your fingers, right? So, for example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So those are whole numbers. Now, whenever we try to square these numbers, the result is called a perfect square. So 0 squared is just 0, 1 squared is just 1, 2 squared is 4, 3 squared is 9, 4 squared, 16, 5 squared, 25. Yes? So these numbers should start looking familiar to you. In fact, you should have them memorized. If not by now, then quickly memorize them, please. 11 squared, let's see, I always forget that one. Is it 121? Is that right? See, Mr. Wilsey doesn't even have them all memorized. 121, or at least he's not as confident as he should be. 12 squared is 144, and so on. Okay? So these are all perfect squares. Now, as we just saw here, whenever you take the square root of a perfect square, for example, square root of 49, is 7. Okay? So let's look at another example of simplifying radicals. Example 2. That will use this list here. What if I ask you to simplify the square root of 72? Now, 72 is not a perfect square. It is not in this list of numbers. So that means that when we try to take the square root of it, it will not give us a nice, pretty whole number. In fact, we can real quickly calculate what the square root of 72 is. Square root 72. Eck, it's an ugly number. And in fact, the TI Inspire cuts off the number. It actually continues infinitely. It goes on and on and on and on. So it's a very ugly number. And I hope that you recall that if you try to take the square root of a number that is not a perfect square, this whole thing is called an irrational number. Okay? The square root of any number that is not a perfect square is irrational. Anyway, that's beside the point. When I ask you to simplify the square root of 72, I'm not asking for you to calculate it. I'm not asking you to give me one number, one ugly number. What I'm asking you to do is, first of all, identify the largest perfect square factor of 72. Okay, so that's the first step, okay? So let's try to identify the largest perfect square factor of 72, and let's see where that takes us. Let's see, how about 4? 72 divided by 4? Yeah, so 4 is a perfect square factor of 72, but is it the largest? How about 72 divided by 9? Yeah, 9 works. How about 16? 72 divided by 16? No, that doesn't work. How about 25? No, it's not divisible by 25. How about 36? 36, yeah, 2, okay? So it turns out that 36 is the largest perfect square factor of 72. So that means that we can rewrite the square root of 72 as the square root of 36 times 2. Okay, good so far? Now, watch this next line. Watch what I'm going to do. Square root of 36 times square root of 2. Notice what I did. I split the square root into two parts. This is using something called the multiplication property of radicals. The multiplication property of square roots. Okay? It just says that I can break up a square root into multiple parts if I'm breaking it up over the operation of multiplication. Okay? Now look at what that allows us to do. The square root of 36 is 6. So I can simplify that into a whole number easily. But the square root of 2, well, 2 is not a perfect square, so the square root of 2, I'm just going to leave it like this. Okay? So the way to simplify the square root of 72 is to write it as 6 times the square root of 2. And if you want, we can double check that. 6 times the square root of 2, enter. That number is the same exact thing as the square root of 72. Okay? Now the question is, why in the world did we do this? That's a great question, and I don't know the answer to it, okay? All I know is that the goal of simplifying a radical is to take out any perfect square factors from inside the radical. Take out as many perfect square factors as you can, okay? So that the number inside the radical, that's left over inside the radical, is as small as it can be, okay? So the first step here was to identify the largest perfect square factor of 72, and then, so that turned out to be 36. Then take the square root of the perfect square factors. Okay? But just remember that the overall goal of simplifying radicals is to make the number inside the radical as small as possible. All right? So let's just look at another example of this. This is an objective that you really just need to see in a lot of examples, and you just need to practice. So how about simplify square root of 160? Let's see. Are there any perfect square factors of 160? Well, 16 might work. That's probably going to be the biggest one. Okay? So we can rewrite the square root of 160 as 16 times 10, right? So we can look at the 10 now. 10 does not have any perfect square factors, of course, except for 1, but that's not going to help us out. Okay, so now we're going to split this radical into two parts. Square root of 16 times the square root of 10. So we're breaking the square root up over the multiplication. Square root of 16 is just 4. Square root of 10, we're going to leave it the way it is, because 10 is not a perfect square, nor does it have any perfect square factors left inside of it. So that is done. That is it. We have successfully simplified that as much as we can. Okay? Now let's take a look at a slightly more challenging example, and you tell me why it's more challenging. Simplify, let's say, square root of 16x to the 4th. Why is it more challenging? Well, because now we have an x in there. We have an unknown, a variable. Well, it turns out the way to simplify this is exactly the same as what we did up here. Okay. First thing, let's see, the 16 is obviously a perfect square. So that's going to be easy to deal with. So if I split this up into square root of 16 times square root of x to the 4th, that'll be easy enough. Square root of 16 is just 4. But how about the square root of x to the 4th? How in the world are we going to deal with that? Can we deal with that? Why, yes, we can. Remember that x to the 4th is the same thing as x times x times x times x. Now let's rewrite this in a different way. X times x is x squared. And x times x over here is also x squared. So x to the 4th is the same thing as x squared times x squared, right? Now, let's rewrite it so that it says x squared times x squared. And then let's break up the let's break up the radical over the multiplication. What is the square root of x squared? Well, it's just x. And then square root of x squared here is also x. Okay, so now we have 4 times x, which is just 4x squared. Okay, so it turns out this is the simplest form of 16x, of the square root of 16x to the 4th. Now, I have a lot of steps here, but to be honest with you, as long as you can find some way to go from here to here, I don't care what steps you take to get there. In fact, I probably showed too many steps. As long as you can find a way to get from here to here, then you're golden. And in fact, for this unit, since I dislike it so much and since I think it's kind of pointless, I'm going to make this into multiple choice. Okay? All of the problems you're going to be doing is multiple choice. So as long as you can find a way to identify the simplest form from your list of choices, then you're fine. You're golden. Okay? Let's look at one more, not one more, at least one more example of this. Let me find my pen. Here we go. Example 5. Let's try to simplify square root of 54 times n to the 7th power. Okay? Now, first step, 54. Does 54 have any perfect square factors? 54 has a 9 in it, right? Let's try that. 54 divided by 9, 6. So 54 can be written as 9 times 6. N to the 7th, let's try to write that as squares. N squared times n squared times n squared times n. Just a leftover n, right? You see how I got that? In order to get n to the 7th, you would have to add up 2 plus 2 plus 2 plus invisible 1 to get 7, okay? Now from here, I can see that I have a square root of 9 times the square root of 6 times square root of n squared. Again, I'm just showing a lot of steps here. If you can break away and do this all on your own, feel free with as few steps as possible. The square root of 3 is just 3. Square root of 6, we can't simplify that any further because 6 does not have any perfect square factors in it other than 1, but that's not helpful. Okay? So the square root of 6 needs to stay the way it is. Square root of n squared is n. Square root of n squared is n. Square root of n squared is n. Square root of n, we can't do anything with that. It has to stay the way it is. Okay? Now, one last step. Let's just rearrange everything so that we get all of the free stuff, okay, all of the stuff that's been freed from the square root. Let's bring that to the front. So 3 times n cubed times square root. Now we're going to recombine the 6 and the n inside of 1 square root, 6n. Okay? So this is as simple as we can get, even though it actually looks more complicated. But again, I don't care how you get from here to here as long as you do. All right? Let's look at another example. How about this? This is a quick example. Simplify square root of 24 times square root of 6. Okay? Now here, how in the world are we going to deal with this? Well, it might be helpful, first of all, to combine this into one square root. See where that gets us. But Mr. Wilsey, isn't that the opposite of what we want to do? Yes, but it might help in this case. Watch. Square root of 24 times 6. So we just bring them under one house. What is 24 times 6? 140. Oh, 144. Interesting. So the square root of 144 is a number that should be familiar to you because 144 is a perfect square. So the square root of 144 is just going to be 12. Right? Let's see if that works out. Square root of 24 times square root of 6, 12. Yeah, it does work out. Perfect. Okay? So in this particular case, it is clear that we actually did simplify these radicals because the number is very simple. But in other cases, it won't look more simple. The basic idea, again, is to get as much out of the square root as you possibly can. Sometimes, though, that requires us to combine the square roots or do other sorts of weird things, okay? To do tricks, essentially. Now, let's look at one other example, maybe. Yeah. How about this? Example 7. Simplify. You're going to get tired of that word after a while. Square root of 64 divided by 49. Okay? Now here, guess what? We can rewrite this as square root of 64 divided by square root of 49. Okay? In the exact same way that we can combine and split across multiplication, we can combine or split across division, okay, using the division property of radicals. Now here, square root of 64, well, 64 is on our list of perfect squares. Square root of 64 is 8. Square root of 49 is 7. So 8 over 7 is a fraction, and I hate fractions, but it's simple. It's simplified, okay? Okay, now, let's look at one last example, I promise. Example 8. Simplify square root of 8x cubed divided by 50x. Okay? So here, first thing I notice is that I have an x cubed on top and an x on bottom. I can cancel out one of the x's, right? So up top, that becomes x squared. On bottom, the x goes away. Okay? Nothing magical there. I just canceled out an x from the bottom and the top. So sometimes it helps to just focus on what you've got inside the square root and then deal with the square root. Okay? So here, what can we do here? What if we split the square root like this, 8x squared? So I'm just kind of going aimlessly. I've never worked out this problem before, but you can kind of see my thought processes. Square root of 8. Let's see. 8 is not a perfect square, but 8 does have 4 as a factor, and 4 is a perfect square. So what if we write the top like this? 2 times 4 times x squared divided by, now 50. Does 50 have a perfect square factor? Yeah. 25 can go into 50. So let's write this as 2 times 25. Good so far? Now, from here, let's see, square root of 2 times square root of 4 times square root of x squared divided by square root of 2 times square root of 25. Good, good. Now here, let's start to simplify. First thing I notice is that there's a square root up top. Sorry, there's a square root of 2 up top and a square root of 2 on the bottom. Everything is being multiplied here, so guess what? Cancel that guy out. Square root of 4 is 2. Square root of x squared is x. And then on the bottom, square root of 25 is 5. Hey, that looks pretty simple, right? 2 times x divided by 5. Turns out that is the simplest form of this expression. And in this case, thankfully, it actually does look a lot simpler than what we started with. Okay? So that is all of the examples that I'm going to do for now. So I hope that you are ready to start practicing.